So I want to take a look at interference, right? So we talked about this last day, right? We talked about this a little bit, right? Well, when the wave goes in here, undergoes diffraction, right? And the diffracted waves undergo interference. And if I put a screen here, what will happen here is there are points of constructive and destructive interference. Constructive, destructive interference. And that pattern is called your interference pattern. Okay? So the separation between the fringes, which we call Y, is affected by three factors. And I told you all the factors. You probably can't remember it, right? But yes. Right? The separation here. The what? The wavelength. And the separation here. Me, I would love to start over. I would love to start over. You know, so I would love to start over. All right. So these are the three factors that affect the separation of the fringes. That's okay. Today we're going to do the proof to come up with a formula that relates all of them and then do some applications on them. Huh? Watch this video already? Very good. All right. All right, draw this quickly, and I want to do the proof, right? Do I draw? No, I'm gonna draw it here. Huh? Who else doing? The one that walked it. Right, my letters will be a little bit different in letters in the notes, right? Just a little bit different, but the same principle, right? I use different letters. All right, everybody watch here. Right, so you'll understand what's going on, right? This me, you know, coming upstairs. You know how long we start? All right, so watch here. Here's what we're doing, right? You're trying to find a formula that relates the distance between fringes and this distance between the screen and the fringe pattern. The distance between these two, let's call it small a, right? And the wavelength of the light coming in, right? We have light coming in here, wavelength lambda. That's okay? No, that's wrong, that's the fraction rate. All right, so watch here. Here's what's happening, right? Everybody watch here now. So when I join that, we know where you join, right? So whenever the array leaves here and array leaves here at the same time, when they travel from here to here and here to here, the difference in paths, right? There's a difference in paths. They don't travel the same length. Watch this here. If I draw a line from here to here, and I draw a line from here to here, both of them are the same length? No, one longer than the next, right? right? So there is something called a path difference. There is something called a path difference. And here's the unique or nice thing about the path difference. You all might remember there's some phase difference, right? You all remember when we did phase difference, right? Well, what does in phase mean? Crest meeting, right? So when something in phase, they undergo constructive interference, and they would produce a bright fringe, right? Right. When something in phase difference is very similar to path difference. Whenever something has a path difference of 0 or lambda or 2 lambda or a whole number of wavelengths, whenever the path difference is a whole number of wavelengths, what you end up with is a bright fringe. You'll end up with a bright fringe. So here's what that's saying. If I were to minus these two parts, and when I work out the difference between them, again a whole number, a wavelength, I can do wavelength is 4 meters, and I end up with 8. It means that where those 2 points met is a point where a bright fringe is. That's okay? But if it's a half number of wavelengths, then it will be in between. Then it will be that. A little lame joke on this one. Technical terms. Like one of the limits. That was a good one. Okay. That wasn't good? One limit. Show it to me, and I want to show you the proof, right? Show it up to me. Huh? That's now that the exciting part. Oh, that's the exciting part, I can tell you. Oh yeah, draw this quickly. Excuse Marquis, draw this quickly online. Draw this quickly. I want to do the explanation, please. Fire. Why? Because it what? Are you ready? Let's go. You ready? Right? So again, the point of all of this is to find y. What is y? Right? Olha. In the middle here, putting a point C, right? In between A and B, put a point C. Hey, don't need a point C. After crash course, we can run some more things, but we got it like that. Technically, it might be much more. After crash courses, there's a week. But that week is your night, I think your exam is the next week. Physics. I think it's first, huh? Yeah. But I will show you, I will show you. All right, ready? So watch here. Everybody watch here. So how do I attempt to find y? The first thing I'm starting with is this. I draw another triangle here with P, C, and O. Right? I draw in a triangle because I want to compare or equate that triangle to something else, right? So let's call this theta. Right, watch this here. Something real important is this. If I were to draw a line down here, A, and it touches the line BP, that point, let's call that point N. The angle it makes here is 90. And if I do a little bit of maths, here's theta and here's also theta. All right? So those are the important things that we need to get. Okay? This angle and this angle is the same. You do similar triangles and here is the same. All right? But here's what I want you to see. You're watching? Everybody watching? And here this is very important, right? What's this here? Beta N is what? That's the difference, right? So beta P is longer than eta P, correct? By how much? Yeah. By that. Right? So this beta N is your path difference. Right? And since it's the path difference for the first bright fringe, then that corresponds to lambda. Right? See if this makes any sense, right? So you're starting here, and when they both travel to O, the path difference is how much? If they start here and they travel to O, the path difference is what? 0. Did they travel the same length? Eh? From here to here is the same length. So the path difference is 0. Now to the first bright fringe, that is central, right? Now to the first, the path difference according to this will be lambda. To the second bright fringe, their path difference will be, and so on and so on and so on. Right? So now we could see that b to the n is lambda, right? But watch, we could also find b to the n here, right? If we do a little bit of maths, we will see that if we use sine theta, we will see that sine theta is equal to opposite over hypotenuse. Opposite is b to n, and hypotenuse is A. A is the separation between the slits. I just draw a line down from A. Well, a line that will meet this perpendicular. Now arbitrary line. Right? So sine theta is this. You okay with that? So Faith, since sine theta is equal to this, right? Can I use this big triangle here? Can I use the triangle PCO, that big triangle, and find theta? Yes. PCO. I have opposite and I have adjacent. So I could write what? Tan, right? Tan theta is opposite, which is y, over adjacent, which is d. Y over d. And for all the pure math people, if theta is small, what does that say? It says that sine theta is approximately equal to tan theta. Yeah. Remember that? No, you don't remember that? There's not a limit, so. Yep. Right? Limit of sine theta on theta as theta approaches 0 is 1 end. Yeah? And same thing for what? Tan theta and theta. So it means that these two things technically equal. Okay? So these two things here equal when theta is small. Okay? When theta is small. So what does that say? That says that Bn is lambda on A. That says that lambda on A is equal to y on D. Please note it's approximately, right? If I rearrange this formula, I'll get y is equal to d lambda on E. All right? Huh? This is on the syllabus and there's asking to prove it. Sorry? Yes, sir. Did you watch the video? I did. I did, but I was copy it up.
No, I'm going to do something. So I sent it to you on WhatsApp from the office. Also, as parent, she's at the daughter to learn for 6 of she's getting the career. Yeah, right. Well, it is incorporated. Right. So I just wanted to come to I don't know if the phone is you. I don't know if the phone is for backup or record. I don't know. I saw it to. Well, he said something you went to me today. Said it to all.
Copy it down there.
Why are you doing this? They show up every day. See first.
That's where we do the proof here, right? You're okay with that? And yes? Take it after the proof is signed. Alright, let's go again. So, everybody remember what D is, right? And you can make a note of it. D is the separation of the screen from the fringes. Sorry, the screen from the slits. A is the separation of the slits, and lambda is the wavelength coming in. Okay? D is the separation of the screen and the slits. A is a separation of the slits. Lambda is the wavelength of the light coming in. Sorry? That's all good. You want to pay attention all the time. All right, next one. What? Lambda is the wavelength of the income. Chief of that, Mike, what do you have any?
This is on.
Yeah.
This guy, yeah.
All right, let's go. Let's start here. Right, instead of me counter, just write down the important things. Number one, given the wavelength of yellow light and the separation of the yellow fringes and the spacing of the slits. Yeah, 10 to the minus 7. Marquis, with the question number. Write it down. Write down what they give you. Right? What you all got? So what they gave us here, they gave us the wavelength What is the separation of the yellow fringes? So what is Y? They give you the separation of the screen, that's D, and the spacing, which is A. So the formula we're using is what? Y is equal to, right? Y is equal to D lambda on A. Right? So that is 1.8 by 5.89 by 10 to the minus 7 all over 0.2 by 10 to the minus. Oh, you all sign up to the course, right? You also got the form already. Right? And I'm going to share if you can share it, like if you have to press the name. Work it out, I'm away, get to Y. What shall I get for Y? Right? 10 minus 9. Sure. Check it back again. Massive bigger one. What is
I already finished that. I get D. Look. 5.3 by 10 to the minus 3 meters.
Now maybe it's struck right there.
Yeah.
What are the cases of the come by? So like it's money. So like it's on my online, you'll get up to 5.3 millimeters.
Thanks.
Take which one. Yeah, no problem. I told her already, but. But I push it comes down a little bit.
And then why put it vertically? Because some people could record, some people could again, so why they can't take vertically, I think I'm first to play.
I do it time until I get it.
Some people probably do.
Part 2, you want to stop there? Try that, please. One and stop, right? Not the part underneath. Try that fast. Book out your answer, message your answer, right? Online, please send something. Please. Please. Wait, Katrina, you the assignment. Can't believe that. Oh yeah, we'll go that fast. Correct, yeah, again.
It's up by 1 4 by 59 right? Oh. Yes.
Oh yeah, we'll go down.
I guess I'm going to go like that. But, you know, what the does, Itu I thought the only there. Just like there's not only I thought
How much y'all got? We still know what's got online garage. Follow on, send us garage. Huh? Move quickly. Right, what we have here? We have A. We have T and we have Y. So Y is equal to D lambda on A. Lambda is equal to Y A on T. So that is 1.44 by 10 to the minus 3. What A again was that? 0.2 by 10 to the minus 3 all over 0.5. Your answer should generally be to the minus 7 around there, right? How much you got? No, you can put it in nanometers after. 5 point. That's not nanometers.
No.
Right, so what would the answer be in nanometers? So it'll be 560 by 10 to the minus 9. So that'll be 516 nanometers. So you must write your answer as minus 9. So 5.6 by 10 to the minus 7, right? So if you go to the minus 9 in minutes, to the right, one time.
So this one makes sense. It makes sense. And it was like,
It's a 9.
No, it is right now, it is -7.
yeah, that's what he does.
Right, -7 meters.
That, and then you want.
So you wanna go to nano, nano is 10 to the -9. So write it as, so to go from -7 to -9,
Yeah,
you go to the right,
but the -7 is in meter already.
right, and then the -9 is in meters.
Ten, just like meters, and you want to come to the nanometers.
Alright, I'm gonna do it slow for you, I'm gonna do it, right? What do you think? Right? If I have 0, say that, no.
I think you don't know.
If I have 0.01 meter, how much is that? 1 by 10 to the -2, correct?
Yeah.
If I have 0.0001 meters, how much is that?
That's 1 by 10 -4.
Correct? All in, let's say, meters, right? You okay with that? Nice, so watch this here, look at the first value. Right, suppose I had 1 meter. And that's 1, well, 1 by 10, right, let me change that, sorry. 0.1 meter, and that's 1 by 10 to the -1 meter,
Yeah.
right? How did I go from here to here? Alright, simply doing this one here, how I went downwards? How I went from 0.1 to 0.01? I divide by 100, right? But by 10, sorry. Okay, and what happened here? The value decreased by 1, right? That's okay. So I want to get, I have something by 10 to the 7. How do I turn it into 10 to the -9? What would I do now? Divide by 100, right? So, and then if I have 10 to the -9, I can remove it and just write nanometers. So just working in nano. Yeah, I'm not making any sense.
No, I say a
Alright, I'm gonna do the long way. I'm gonna do the longest way. You should see it. Right. What was the answer? 5 point. What's the answer? 5.6. 5.6 by 10 to the -7. Watch this here. Watch this, Sylvester. 1, 2, 3, 4, 5, 6, 7. Que bota abaixo, né? That's the value on top, correct?
Yeah.
That's the value on top. Same value. Right? I want to take that same value and write that value as nano. Start the way. If I have 560 now by 10 to the -9, if I write that, I'll end up with 0.00056. So you would recognize that they are the exact same value. So in short, to convert 10 to the -7, 10 to the -9, all I really have to do is move it decimal place to the right 2 places. Okay, that's all. All right. If you convert 560 by 10 to the -9 and 5.6 by 10 to the -7, you get the same thing, right? All right. Hopefully that was helpful. Try this next one here. Watch this here. So if you look here, this was the year where they actually asked us to prove it. I know where to prove it, right? Yes, do one part. Watch it good. How are you going to do part one? Right? How are you going to do part one there? Right. So you have to draw the diagram on board and you have to work it out. 5 marks. Okay? Otherwise, do it now. Just do part two. Hurry up.
That's the diagram.
Get the diagram. What is zero?
I don't have to get it for the other.
You're there about with no diagram. How you how do you work it? Hi, good.
It was in December, but it's the same thing.
Just ask, we.
Oh, okay, sorry.
Hey, some of us are gonna get the first singing. I redemption, dancing hours.
Look at again in this question. You have to prove it again. Right? Right. Explain the one before was 2018 or 9. Right. This one's the old one. Question here earlier. Ignore the proof again. Ignore part one. But can you all explain this? Why is the formula Y is D lambda and A approximate value?
Oh, because you have to approximate sign, to approximate.
Right. Because in the proof, Javed, in the proof, we said that when theta is very small, sin theta is approximately tan theta.
Yeah.
So you have to tell them that. Right? Because theta is very small, we approximated sin theta to be equal to tan theta. That's why it's not the exact thing, right? The approximation. Remember, I didn't write it here. I forgot to write that. Right? I forgot to write that D is much, much bigger than E. So imagine this, right? Imagine this being much further apart and A being real small. It'll make these angles here very, very small. Okay? Right? So just add that in for me, please, and take proof. D is much, much bigger than E. I left that out, sorry. D is much, much bigger than E. What's that? What's that eating, sir? That food good? Very good.
It smell like soup. It smell like soup.
Well, it's so oh, I was no why I think so what that's something. All right. You're okay with that? When's that, ma'am?
Because I mean.
Theta is very small.
Yeah.
We approximated sin theta to be equal, right? And the reason we did that is because D is much, much bigger than E.
These ones, okay, yeah, I get you.
So, we can explain how we are, I mean, why is it? We have a video. We're just like, it's like video.
Try this, please. Next part. Try this here, please. Yes, sir.
What is that? That's not gonna say, they baby and over here.
Hold on, I'm just trying to zoom out of it.
Yeah, she have a for that. This is my. It's on
Almost said, but watch it.
Thanks, thanks.
All right, That's the best I can do there.
So I feel I'll do a perform that then 4 or 5 months.
Okay, let's please. Try this, please.
So what this is?
Pick a picture. I'm trying to make it.
So you just
Not good yet? Start there, hurry up. Yes, please, how can I help you? Come on, Olivia, we have to go to.
So what we need to
Empty this way. Empty this way. And here is. Sign of that isn't real life. Real life, that situation. Right, so what? So what? I was gonna be. Right, I left all that part stuff. Because he is so big and he is so small, theta values and comparisons. Just imagine stretching that diagram, theta will get real small, that diagram said, oh, yeah. Right? But you don't understand what you take it at once. Pull that up, pull that far, and then make it smaller. And that theta value don't get real small. Yeah. And if theta is small, you can make it theta, put it through.
See, I don't do it.
Right, so you have to learn that, sin theta. Yeah.
I see it.
That's right, that's true. So every day.
Hurry up. We'll go that, find part 1 and part 2. Part 1 only is Pythagoras theorem, right? Yeah, use Pythagoras theorem to figure it out. Okay, guys, help you along the way to that way. Just it's helpful. Right, I think answers coming in online already, yeah? Answers coming in already.
That's what it's saying.
Hurry up. Is that fast? Yeah. Come on.
People have a big one incidents. People have a big one incidents. You get it?
I go back in the back. I go, you're gonna get rid of it.
Yes. Yes. Hey. Yes.
Ready? Peter, why is a straight line? How long? 6 meters, good. How long is Peter X? Sorry. How long is Y to X?
Y to X by root to X plus half of 1.
Very good.
Yeah, very. What the X plus half over point five? Yes.
No.
Alright, okay, guys.
You can select from down
Yeah,
here.
yeah, yeah, yeah. You are not stuck. You are not taking
Right, what's it here?
So why you started? Peter will 2.5 later, right? And then root to X 2.5. So half of 1.5,
Yeah.
2.5 is right there. And then you just use by target.
Right, you're seeing that? Right, so Peter Y is 6, O to Y is half of this. Right, here to here is 1.5, so here to here is 0.5,
It's not right. That's
right? And they wanted to find PX. How we getting PX Atelier? How we getting PX? What kind of triangle is that, Atelier? Right? So you could use Pythagoras theorem. Okay? So you could use Pythagoras theorem. Marquis, after you find CX, right? And you find QX. Diane. Marquis, after you find PX and you find QX, how are they going to help you find wavelength? Something is still on the board. After you find PX and you find QX. Yeah.
So then the opposite then, O equals C, I'm gonna C to one.
After you find
So if what's
After you find PX and you find QX, how does that help you find the actual wavelength after?
Because
Excellent. Right? This young man said find the part difference. So to find the part difference, what are you doing? Young man, what are you doing? And the answer, we have on it. Right? So when you minus them, right? You'll get the part difference, and the part difference for the first bright fringe is how much?
theta? What is that?
Lambda. Oh,
That's our.
okay, go ahead. Find PX, find QX, and minus them.
Actually,
Yes, because instead of
and one.
X, actually the first maximum.
This
Oh.
range.
Well, this is sound third maximum. They use sound in this example, we use light in our example. Half six. Come on, I want to do one more thing after this. Oh yeah.
So and we have a wait.
Yes, elastic. Politics, come on, do work if all I want.
Tell you that.
If you could.
Yeah.
If you want to do it, just.
So we can practice now, correct?
So.
Right. Sunday I used to do anything, so you can't come knowing nothing. So you're gonna be asking you will be niche where you know what I'm correct. I can narrow it down to like what you want to do and I can narrow it down to what but if mine, we find me like alright, hurry up. Hurry up, please find. How much you all got with PX? Find PX fast. PX, QX.
Oh.
Yeah, it's not the same thing.
I know this.
Ground roof, ground glass. How much you all got? Book it out and minus it.
So, was it predicted based on
Book it out with. Minus them more you get. You'll see what I get 1.75. Right? PX here is 1.75, right?
Yeah.
Some of the answers now, please. Oh yeah. Yes, blue color thing. Marquis and Vinesh, you have to do the question, please. Marquis, when you're working on your work, yeah?
Why don't one of them different?
Supposed to be.
So, go and I let it put me up to the
Zero. Any answers? Right, Katrina got 6.82. Anybody else got up? That's yeah, when am I? Oh, like it's PX, okay. What you got to PX minus QX?
I gave it 1.69. You guys are 5
0.57, right?
I have 6.9. Oh. I have 0.69. Yeah.
That's 3.25, huh?
Yeah.
1.25.
1.75.
Oh.
1.75. Right, nice. Next one. They want you to find wavelength now using the formula. Find it fast. Use the formula and find wavelength. How much you got reach? Yeah, the first part 0.57. Right? Use the formula now. Use the formula and define wavelength. Are you getting this, right? Huh?
Just want to use it for like 1 second. Right.
After this is what? Use the formula. Use the formula and find lambda. Which one do you so cool? When it comes to it, you sign theta and lambda. You can get it. I want you to talk about that. Sorry.
And then you got benefits of the ones.
I want to read. Next week I will be there. Let's go all the items. In this case, yeah, but they want change part 2 to use the formula. Use the formula Y is lambda D on A.
Right, find wavelengths, right?
Yeah. So lambda is Y A on D. What is Y phase? From a diagram. What is Y? Phase, what is Y? How you get that? So why do it again using the formula? What value does the formula give you? All the really things now? Huh? Very good. Y is 2.5. Right? That's between O and X. A is how much phase? Come on, let's not get one right phase. A is what? What's the diagram? A math 1.5. If I'll grab there. And B is what? My diagram. What is C? Hurry up, do that fast. That's one phase here. Get 2 out of 3 and fast. What's the diagram fast? What is D? Phase, just relax. Yeah. How much is that?
This one, speed of difference.
Yeah.
This one, speed of
Yeah, but if you work out after month, how much you get?
I mean, it's what?
Yeah.
0.57.
So it cannot be 0.57. To your point? Right. Why are they different? One is 0.625 and one is 0.57 yards. Why are they different? What? Why are they? Come on, face the board. Come on, face the board. Right, very good. Right, so which one is more accurate? Which one is more accurate? The first one is more accurate, very good. You follow why?
No, because they are approximation.
Because part 2 is an approximation, part 1 is not. Okay? So use the appropriate answer and find the last part.
What is the other word? What is be something more? From
Peter or different separation.
no,
Yeah. From fringe to fringe, that's called a fringe separation. This question, they didn't use light, they use sound. So instead of fringes, you will hear maximums. Right, question, find frequency, that should be easy, right? P is equal to F1 lambda. Which lambda are you using, Darian?
the good one.
The good one, alright, nice. Alright, last question before you wrap up this. Now go to Dale. No, not Dale. Sorry.
Yeah.
Sorry, I forget.
Yeah. Once again. Actually, I see
I forget. The deal, huh?
It's already, yeah, they know.
The lot? Or DY? Alright, Dylan, last thing. Dylan, here's what happened now. I'll tell you, I understand. So, alright, Bob, initially PNQ were in phase, but here what it do now. The phase of the speaker P is changed to 180. So it means that P and Q are now what? Out of phase, opposite.
Yes.
What effect will this have on the sound heard at O1X? So going back to O1X. What will happen if the outer phase?
Yeah.
What will flip?
One what?
Yeah. What will happen?
One what?
What will happen at O1X now? What will flip? What will flip? So if two things in phase, what kind of interference is happen? And if the outer phase. So what do you think will happen at O1X? Right now, O1X have constructed right loudness. So now, since the out, it will have this structure, so it will be soft. Okay? So what do you expect between O1X? Between. So right. So O1X is now soft. So between O1X will now be loud. Maximum. Okay? So the question asks what I expect. You expect minimum. You okay with that?
Yes.
So you probably write it down. Right there, write it down.
Yeah.
Alright. Last thing I wanted to talk about that we kind of mix up here is this. Right? I will elaborate a little more on this on Saturday, right? Sunday, I mean. Watch this here. There is something. Hey, so I'm not playing outside. Nothing this class, we talk them outside. Right. During interference, we know Y is equal to D lambda E. But there is something special that happens here in something called a diffraction grating. Alright, watch this here. In a diffraction grating, right? So imagine a ruler 1 centimeter long. Let's pretend here to here 1 centimeter. Right? Here to here 1 centimeter. Right? So imagine in 1 centimeter, you have 1,000 slips. So you have a glass, let's say, right? So the glass is 1 centimeter, and within it you have 1,000 slips. The space of one of those slips, right? The space of one of those slits is what we call A. Right? The space of one of those slits is what we call A. If we allow light to pass through here, right, it will produce a pattern, right? Kind of similar to what we have here, but we call it a diffraction creating pattern.
Yes.
Right? And that pattern will be a little bit different. You have the central, You have your what we call N1, order 1, order 2. Right? And the angle between the central and the order is given by a slightly different formula, which we write as A sine theta is equal to N lambda. All right, I'll elaborate on this a little bit more on Sunday, but I want to show you the difference between them, right? This formula is whenever the interference is occurring. This one, we only use it in a diffraction grating, which is very similar. Imagine you have 1,000 of these slits. 1,000 of these slits. When light goes through it, and it will still have interference, right? But the pattern produced is a little bit different. It looks something like this on both sides, underneath and on top. Right? And this is the relationship that we use to find anything in here. Okay? So I want you to know when to use this one and when to use this one. They're all similar, right? The formula looks different, but sometimes we use them in the wrong place. We use this relationship for interfering pattern. We use this once you see the term diffraction grating. Okay? Or orders. Okay with that? So I'll go to the proof picture on Sunday. But I want you to be able to use two different things. So what A again? One slit. One slit technically is A.
Yeah.
Right? Theta is what? The angle between the sensor and any of the order. So here can be theta for order 1. Here can be theta for order 2 and so on. Okay? Papa, nobody there? All right? And N is the order 1 and 2, and lambda is the wavelength. That's okay? The wavelength of the light coming in. You all okay with that? All right. So I just want to show you one application of this. Yeah? All right. So just do a quick little sketch of this and write this relationship. What are you doing? All right, so watch this here. Last thing, all you have done. Last thing. Right? I will do this is the first thing that I'll do on Sunday. So even if it's not there, I'll record it so you can look at these examples, right? So watch this here. A diffraction grating. So what we using? We using Y as D lambda A or
A sine theta.
right. So a diffraction grating has 4.55 by 10 to the 5 lines per meter. Okay? And it's used to examine the light from a it's the wrong one. But it's the same thing, right? I wanted to give you one. Oh, look at it. All right. Anyways, let's just continue with our statement, right? We done with it already. Right, so we have a diffraction grating, and they give you how many lines? They give you the first order. What does that mean? First order, N is what? 1. N is 1, and they give you the angle, right? 11.8. So they give you N, they give you theta, and they give you, well, we have to find A. They want you to find the wavelength. All right? So I want to show you, of course, you all recognize that we're using A sine theta is equals to N lambda. We know the order is 1, We know the angle theta. But we need to use this to find E. Right? Watch how easy it is, watch how easy it is, right? So it's 4.55 by 10 to the 5 is equal to 1 meter. Right? So if you have 4.55 by 10 to the 5 lines in 1 meter, what is the thickness of one line? What you'll do? What is the thickness of one line?
It's
4.55 by 10 to the 5 lines in 1 meter. What is the thickness of one line? 1 over that, right? 1 over 4.55 by 10 to the 5. Right? That's one line. Go wrong the top. Leave it just like that. So if I ask you to find for lambda, what you will do? Your right lambda is A sine theta over n. Okay? A is 1 over 4.55 by 10 to the 5 multiplied by sine theta. Theta is 11.8 and is 1. And it will this out. Right? But the purpose of this whole thing is to really try to understand when to use the right relationship. Okay? Alright. So we'll do some of this on we'll do some of this on Sunday. Next week we can redo this and be done. Okay? But the objective on Sunday is to go over some of the things that I find hard. So what we good is if we come on your table a chance to project that motion. Right? So that's what we'll focus on for a while. Huh? We did the edge, that's the one that we did last week. And I gave you a diagram. And I show you how the scale and thing is. I didn't do the actual A, but I do how the love scale and work and thing.
So we just have our last week. So I mean.
The week before.
When I wasn't there again.